Now let's try to solve this question. This is a Bernoulli equation. If you want to know that it is a Bernoulli equation, you have to check the order. You could see that it is a first order differential equation. That is y prime. Then here too we have some function of t multiplying y. Then here another function is multiplying y to the power n. In this case n is equal to 2. So because of n being 2, remember in our first discussion we said that a Bernoulli equation n shouldn't be equal to 1 and n shouldn't be equal to 0. So this one, because y is to the power 2, it makes it a nonlinear differential equation, and this is a Bernoulli equation. Now let us solve. Solution. We have y prime plus ty is equal to ty squared. The first thing to do is to divide through by ty squared. Divide here by ty squared. Divide here by ty squared. And divide here by ty squared. If you do that, you will get 1 over t multiplied by y prime of y squared. Then plus, here we can cancel out and we will get 1 over y should be equal to, everything will cancel out here, so we have 1. So that is the first step. The next step is to let u be equal to what is here, 1 over y. Then we can differentiate the left hand side and the right hand side with respect to t. With respect to t. So let us differentiate. So here becomes u prime should be equal to, if I differentiate this one, I'll get negative 1 over y is the same as y negative 1. So I'll get negative y negative 2, which is the same as negative y over, which is the same as negative 1 over y squared. So if I differentiate this one, I'll get negative 1 over y squared. But remember, we are integrating with respect to t, so implicitly you multiply by the derivative of y, so y prime. Now we can multiply through by negative 1 to get negative u prime is equal to y prime over y squared. So now we can do our substitutions. Let us substitute. So coming back to this, I have 1 over t into brackets. I have y1 over y2, and y1 over y2 is negative u prime. Negative u prime plus 1 over y, and 1 over y from here is u, so we have u should be equal to 1. Now we can multiply through by negative t. I want to multiply through by negative t. If I do that, I'll get positive u1. Then here becomes negative t multiplied by u. Then should be equal to negative t. Now you can see that this time, this expression, the differential equation here, is a linear differential equation. So we can solve this using the integrating factor. Now let's find our integrating factor. Our integrating factor, u, is giving us e to the power, the integral of the coefficient of the dependent variable, which is negative t dt. And if I integrate this, I'll be getting e to the power negative t squared on 2. So that is my integrating factor. The next thing is for us to multiply this linear differential equation by the integrating factor. So that will give us e negative t squared over 2 multiplied by u prime, then minus t multiplied by the integrating factor e negative t squared over 2, then multiplied by the u should be equal to here to negative t multiplied by the integrating factor, which is e negative t squared over 2. So that is it. And when we get to this point, we can simplify the left hand side, which will be the integrating factor negative t squared over 2 multiplied by the dependent variable u, then all prime. They should be equal to the right hand side, which is negative t e negative t squared on 2, negative 2 squared on 2. Now we can integrate both sides, integrate here and also integrate here. If you do that, you will get the integral sign will cancel the derivative, so we will get e negative t squared over 2 u should be equal to, now we have to integrate this. To integrate this, I'll bring the negative t out, then I will integrate e negative t squared over 2. There is a dt here, dt. Now we can do this using the u substitution, but I'll solve it straightforward. So I'll get e negative t squared over 2 u should be equal to, first of all, I have to integrate the exponent here. If I integrate the exponent here, I'll be getting, no, the first thing is to differentiate. Rather, you have to differentiate the exponent. If I differentiate the exponent, I'll get negative 2t over 2. And if I cancel out, I'll get negative t. So the negative t will come and divide here. So negative t Then now I integrate the whole exponential function. If I integrate an exponential function, I'll get the same thing, e negative t squared over 2. Then you add your constant of integration to it. Now let us simplify it. If I simplify it, I'll get g negative t squared over 2 multiplied by the u, then should be equal to, when I cancel out, I'll get negative e to the power negative t squared over 2, then plus the constant c here. Now from here, we can take the total derivative of it. That is going to be e negative t squared over 2 multiplied by the u plus e negative t squared over 2 should be equal to a constant c. But if I take a total derivative of it, if I take a total derivative of it, then it will be equal to 0. Therefore, this is my potential function. This is my potential function, and the potential function is always a function of t, and a function, this time it is u, so a function of t and ut, which is a constant, but if I take the derivative of it, then it is 0. Therefore, my potential function is a constant c. Now, the potential function is what is in the bracket, so I can say that g negative t squared over 2 multiplied by the u plus g negative t squared over 2 should be equal to a constant. That's the potential function is equal to a constant. From here, I can divide through by, there are two ways of doing it. If I like, I'll factorize u plus 1. Then this will multiply e negative t squared over 2. And this should be equal to c. That is, I have factorized e to the power negative t squared over 2 out. Then I can now divide through. If I divide through, it becomes u plus 1 should be equal to, when I divide here, it goes up to becomes c e to the power positive t squared over 2. Then my u will be equal to, u is a function of t, which is equal to c e t squared over 2 minus 1. So this is the answer, but we are not done. Remember, from here we introduce that u is equal to 1 over y, so we have to substitute that back. So it means that our u can be written as 1 over y. Then it should be equal to c e t squared over 2 minus 1. then I can reciprocate. If you reciprocate, you'll get y of t. Y of t should be equal to 1 over c e t squared over 2 minus 1. That is the solution to the equation.